Okay, let's have another look at those last two events. I've circled them now, both. This is one event. This is where the red die is equal to 6. And the others is all put together are where the outcomes are even. And you can see we have 3 overlapping outcomes here that are even and have the red die as a 6. And what we saw last time, I'll list on the other board. Let's go over here. And let's see what we have there, is that what we found last time, the probability of getting an even number was 1/2. The probability of the red one being 6 was 1/6. The probability of both, of getting even a total and having the red one equal 6, that gave us 1/12. And that showed that these two events were independent. There's another thing to notice about it that goes back to what we mentioned before about conditional probability. If we look at the probability that you get an even number given that you have a red equals 6, all right? In other words, we know that that red die turned up a 6. What's the probability of getting an even number there? And when they're independent this way, what you find is that this probability of it being even when the red is known to be 6, is exactly the same as it was before. And if you look back at the outcomes we started the video with, you'll see that the 3 out of the 6 that are in this event are in fact even. So that this probability is exactly the same as the probability not knowing that the red was equal to 6. When they're independent, that's what's going to happen. The conditional probability is exactly the same. Now, what if we reverse the order? Suppose we say, what's the probability that the red one's a 6, given that they're even? Well, once again, what we're going to see is if you look at the outcomes we start the video with, if you confine yourself only to the circled outcomes that are even, you'll still see that 3 of those are where the red is 6, and that the probability of getting a red, knowing that they're even, is exactly the same as it was before, is 1/6. And this is another characteristic of independent events, that when they're independent, the conditional probabilities are exactly the same as they were before the condition occurred. Okay. Now, we want some more examples of independent events. And so going away from dice, I thought I'd list a couple more examples, and we'll show the calculations for those having to do with cards. So in cards, let's look at some examples there. All right, let's pick an event A, which is that you randomly draw a heart. All right? So draw a heart. In other words, you pick one card at random from the deck, and then it's a heart. So another way to abbreviate this is just say draw that heart shape. Now, if I consider what's the probability of getting a heart, well, that's the number of hearts divided by the number of cards. What we saw before is that there are 4 suits. Each suit has the same number of cards in it. So in fact, there are 13 hearts, and there's 52 cards. And so the probability of getting a heart is 1/4. It's likewise, the probability of getting a club is 1/4, the probability of getting a spade is 1/4, the probability of getting a diamond is 1/4. So this is our first event, A, where you're drawing a heart. Now let's look at the next event. How about B, draw a face card? Okay, well, remember the face cards of the Jack, the Queen, the King? So if we count up all the numbers of Jack, Queen, and King, if I say what's the probability of getting a face card? Well, there's 3 in each suit. There's 4 suits. That makes a total of 12 face cards in the deck out of 52. These reduce now, and you divide both by 4. You can get 3, and then 4 goes into 52 13 times. So 3 out of every 13 cards is a face card. Okay. Now it turns out these are independent events. If I look at what's the probability of getting a face card that's a heart? All right, what's the probability of drawing the Jack of Hearts, the Queen of Hearts, or the King of Hearts? That's only 3 outcomes. There's only 3 outcomes out of the entire deck that make that true, so that's 3 out of 52. Now, what we should see is that these are the same as the product of these 2 probabilities. So let's look at the probability of A times the probability of B. I guess I'll draw that sign there. Okay, so the probability of A is 1/4. The probability of B was 3 out of 13. Okay, if I multiply those together, you get 3 out of 52. And once again, you're supposed to see that it's useful to reduce fractions to lowest terms so that these things are clear. Let me tip it down a little bit so you can see that. Maybe zoom in a little. Okay, so these two are independent. All right, drawing a heart, drawing a face card are independent events. And what we'd see is, going by the first thing too, if you know one event has occurred, the probability of the other isn't changed. If I know I've drawn a heart, the probability of it being a face card is exactly the same as it was before I knew that. So they're independent. The probability that it's a heart, knowing that it's a face card, is also 1/4, because there are just as many heart face cards as there are hearts in the deck, or at least the proportion is the same. So that's another example of looking at conditional probability and independent events. They're all closely related to each other, and now you should be prepared to do some problems like those are in the book.